Hey everyone, in today's video I'm going to discuss the cause of the EV3's Virtual Machine instruction break error. In today's video I'm going to explain the cause of the error as well as why it's so difficult to isolate the error. I'm also going to explain why previously functional code may stop working for you and also how this problem's been fixed. The VM instruction break error has a very complex underlying cause which has made it very difficult to isolate. However, the LEGO Mindstorms community, the LEGO group, and National Instruments have collaborated to resolve this issue. First, I want to discuss the cause of the bug. I just recently had a conversation with David Gilday, who is a LEGO Mindstorms community partner, as well as creator of the Mindcuber Rubik's Cube solving robot, and he explained to me how this error occurs in the EV3 robots. Oddly enough, the cause of this error is actually not the virtual machine, despite the error's name being Virtual Machine Instruction Break Error. The true cause lies in the compiler. Now, the VM instruction break error itself is really just a symptom of a much larger bug that's going on within the compiler. And for the sake of this video, let's instead call it the branching error, which is a more appropriate name for it. As I mentioned before, it's a very complex bug with a lot of different intricacies, so bear with me as I explain it. So first, before I move on any further, I want to make you familiar with some terms. The first is virtual machine, or VM. What the VM does is it allows a computer, in this case the EV3, to read a set of instructions that it wasn't originally designed to read. So, for example, if I had a Macintosh computer, normally it would run the OS X operating system, which is Apple's operating system. But if I wanted to use, say, Windows 10 on my Mac computer, I'd need a virtual machine to allow me to run that new operating system on my computer. So that's more or less what a virtual machine would do. Next, we have the compiler. And what the compiler does is it kind of acts as the in-between person for the person writing the program and the actual robot itself. Because we as humans like our graphical programming language like EV3G or text-based language like C, and a computer wants very specific instructions written in machine code, which humans can't understand. So what the compiler does is it takes the graphical EV3G program written by the human and transposes that into the computer language, the computer code that a computer would read and be able to understand. So that's the purpose of the compiler. The next term to familiarize yourself is a branch. Now, normally, a virtual machine is going to execute all of the instructions given to it in sequential order. However, we now have branches which will allow the order to be changed. And a branch can be either conditional or unconditional. With an unconditional branch, the VM will always jump to a new address. However, with a conditional branch, the VM is going to check to see if a certain condition is true or false. If that condition happens to be false, then the VM is going to move on to the next instruction in sequential order. However, if that condition turns out to be true, the VM is going to jump to a new address in memory and start with new instructions. So to put this in perspective, a conditional branch is how decisions in a program are going to determine which part of a switch block the program is going to move into. And a conditional branch can also be used to control a loop. It's going to determine whether or not the loop should loop around again or move on to the next bit of code. Finally, the word taken is used to describe a branch that is both executed and jumps to a new address. The size of a branch is called its offset. Now, the EV3 VM will do something to save space. What it will do is it will try to assign the smallest variable possible to store the offset of a branch, and it does this in order to save memory. However, a compiler can't know the size of all of the branches until all of the code has been compiled, and for this reason, a compiler will actually go through multiple phases of compilation so it can determine all of the branch sizes. So the issue occurs when we have branch offsets that are near boundary values. So for example, if you have a branch with an offset of 127. Now we can imagine that the compiler works like this. It's going to go through the first few phases compiling the program, and it's going to reserve 1 byte of memory for each branch, since it doesn't exactly know how large it is yet. When it goes back around again in a later phase, it's going to know how large it is, and if it determines that the offset actually needs to be larger than it originally thought, it's going to need to resize the branch with a larger variable. and if the new branch offset crosses the boundary, like for example we said it was 127, which is the largest value that can be stored in 1 byte, and it crosses the boundary and goes to say 129, what sometimes happens is the compiler will resize the branch's offset incorrectly, so that it will be off by plus or minus 1, and this is where the error occurs. This is especially common if you have branches within branches, and to put this in perspective of the EV3 software, this would be, say, a switch block inside of a loop block. So now let's say, like I described before, that we now have a branch with an incorrectly sized offset. So the program starts, the VM begins to move along executing instructions. Finally, we get to a branch with an incorrectly sized offset. If it decides to take this branch, what's going to happen is, since the offset is incorrectly sized, it's going to bring the VM to the wrong address, and it's going to start executing incorrect instructions. So what could happen is the VM is now moved into the middle of an opcode instead of at the beginning, and it starts reading things incorrectly. Like, it could start reading data as an opcode and start generating illegal instructions. And this right here is where the error occurs. So I hope you followed all that, because this is where the confusing part really comes in. And this is a really difficult error to diagnose and isolate because of a few reasons. The first reason is, even though a surprisingly large proportion of EV3G programs will actually be compiled with incorrect branch offsets, the programs will not always show this error. And the reason behind this is because even if you have an incorrect branch offset, what happens is the error only occurs if that branch is executed and then taken, because your program may run and it may not execute the branch, or it may execute the branch and not take the branch, and in both cases this would pass over an erroneous offset without affecting the program. So the error only occurs if the erroneous branch is executed as well as taken. And in addition, there are so many different symptoms that can come up as a result of this central bug that we have here. As I mentioned before, the VM instruction break error is a small symptom of this much larger bug. There are many other symptoms, some of which may not have been documented yet, but that's what makes this so hard to isolate, because so many errors may occur from this one bug. In general, this is referred to as a Heisenbug, which is named after the scientist Heisenberg. And the reason why it's called this is because whenever you try to look for the bug or isolate it, the bug itself will move. And that's what makes it very, very difficult. Another really perplexing result of this bug is that EV3 code that was previously functional can sometimes stop working and show an error. Now, when you're editing one part of your EV3 program, what can happen is it causes an unrelated part of the program to change, and this can sometimes result in an error. Now, an example of this is if you have a variable and then you add a new variable, this new variable will cause the existing variable's offsets to change, and this may result in an error. In addition, data wires, when they're compiled by the compiler in an EV3 program, they're treated as variables as well, so you need to be careful with those too, because data wires can cause the same error as a variable when you add new ones. This error will primarily occur in my blocks. However, it's also been shown to occur in some other blocks, such as the wait brick buttons block. Now, the interesting thing is, when it's compiling my blocks, the compiler will not compile the my block the same way every single time. Just like I mentioned before, with a my block, if you edit another part of the EV3 program, even if it's unrelated to the my block itself, it changes how the my block is compiled. And this is the reason why, even if you have a completely functional my block and you go to compile it, you haven't changed anything at all within the my block. If you change something else in the program, this can cause an error in a my block that was originally working. And that's what makes this error so frustrating. So the final point I want to address is, how is this being fixed? Now, National Instruments, which is the company that develops this software for LEGO Mindstorms, has received a lot of code samples from the Mindstorms community, samples that would cause an error in the compiler. and National Instruments has gone back. They've investigated the issue, and they've found a solution. And LEGO has announced that within the next few weeks, they're going to be releasing a new version of the EV3 software, which will have fixed the bug as it is understood now. So I encourage you to stay tuned to my channel, because when the software is released, I'm going to have a video announcing its release and demonstrating the old code samples that would normally cause an error, and how they no longer cause an error in the new software. So I'm going to be demonstrating all of that, so stay tuned to my channel to see when the new software comes out. Thanks for watching my tutorial this week. If you found it helpful, be sure to subscribe for more tutorials like this every week, and if you have an idea for a tutorial, be sure to submit it in the comments section below. Thank you, and I'll see you next time. Bye.